Let's have a quick check before we get into it on what version of Excel people are using. Who thought this was PowerPoint? Okay, so everyone's on 2007 or 2010. Okay, so I hope that perhaps you've realised as we've been doing these standard lookups, these H lookups and the V lookups, that although they're very useful and very powerful for doing some data analysis, there are some fairly major limitations to them. One of them is that you can only look up data forwards. Remember, when we're doing our table array, the first column of that table array is where we have our lookup values located, and it's returning the data X number of columns to the right or below. The problem is that we can't look up data backwards. We can't look up something from right to left. So that's one limitation of the V and H lookups. Another limitation is that we can only look up one value. If there are multiple identical values in the list, all we can do is return the first instance of these. We can't do any maths on it, we can't look up multiple values. So that's another fairly severe limitation of the H lookups and the V lookups. So what we're going to do now is we're going to move on to look at some more advanced lookup methods. Specifically, we'll start with using something called SUMPRODUCT. Now, who remembers from school what product means?
Yeah, I think, yeah.
Good, yeah. Means multiplying, doesn't it? Sum is adding two things together. Product is multiplying two numbers or two values together. And the SUMPRODUCT formula does exactly that. First of all, Excel is going to product some numbers, and then it's going to sum the result of those products. And that enables us to look up multiple values and return totals and things like that. So, let's have a look at the example. The example we're looking for is called Advanced Lookups Exercise. And first of all, let's just talk through what we've got here. So in column A, we have months. In column B, we've got two different company names, ABC Corp and XYZ Limited. And in column C, we have two products which they could have purchased, laptop and a printer. In column D, we have some price information. So kind of, A, B and C are text almost. I know A is dates, but these are things which we can look up. And column D is where we might want to sum a total to find out the total that people have spent on these products if the other conditions are true. And as I said just now, the formula we're going to use this is SUMPRODUCT. Now, let's first, before we go and build the formula, let's think through together how the formula is put together. As I said, first of all, we're going to product some figures, then we're going to sum some figures. And two of the things we need to be thinking about as we look through this data are yes and no, or true or false. Or in Excel's case, because remember we're always thinking about how we communicate with Excel, what we're actually looking for is ones and zeros. Okay, so let's look at my lookup example, which we have highlighted just here. So we will be able to change these values in cells G, H and I5 and return a relative total in cell J5. So as we're thinking about how we communicate with Excel so that we understand how the formulas are put together and how they work, let's look through this ourselves. Excel, unlike a normal VLOOKUP, is not just going to look for a single value in the first column and return the corresponding value from the last column. And the reason for that is we've got multiple values for this. So we're looking for January 2011, and I can see in this data two of those at least. There may be more off the bottom of the page. So we need to be able to tell Excel to calculate things where all the values are correct. So it's going to product across every single row of the spreadsheet. It's going to work its way across. It's going to work out a product across here, across here, across here, across here, and then once it's done that, it's going to sum its results. So let's do it manually. We're looking for January 2011. Let's start on row 2. Is that the same? Yes. So Excel, because it's a yes, is going to give it a 1. So We've got 1 in there. ABC Corp, is that what we're looking for? Yes, it is. So we're going to get a 1 in there as well. In column C, we have laptop. And what we're actually looking for is printer. So that's a no. So Excel will give that a 0. And because of the way we're going to type in, the syntax that we're going to use, for these first 3 columns, we'll only be looking for 1s and 0s. And then in column 4, we'll be not telling it to look for a 1 or 0, but to add up the totals. So column 4, we're going to stick with our number of 430. And as I said, Excel is going to calculate the product of these values. So what's it going to get? We have a 1 in column A, we have a 1 in column B, and we have a 0 in column C. And then in column D we have 430. Now what do we get if we multiply 1 times 1 times 0 times 430 is 0, because remember that anything multiplied by 0 is 0. So Excel sticks a 0 in here. It doesn't really, it just remembers it, but we don't have such a good memory as Excel. Let's move on to row 3. January 11, that's a 1. ABC Corp, that's a 1. Printer, that's a 1. And total spend, the price for that is going to be £210. So we have 1 times 1 times 1 times 210. So that will give us 210. Let's just look at row 4 as well. February 11 is a 0, ABC Corp is a 1, laptop is a 0, 430 times 0 is 0. So do you see, where it's doing its calculation, or where we're doing our calculation in column E, we're only getting a value where everything we're looking for is true. So back to the name of the formula, SUMPRODUCT, it's doing its products, and then once it's done every single row, it's going to sum its answers. So it's summing the product of every row in the data table, and the result of that is that we only get a total where everything is true. Makes sense? Good. Okay, now let's put this into practice in a real formula. Let's look at the formula which we use to do this. So, click into cell J5 in your example, and as with all formulas, we start with an equals. Now, thinking about some Excel best practice, you've seen that all formulas, when you look in them, they're in capital letters, they're in uppercase letters. Excel will always change a correct formula into uppercase if you write it lowercase. If you make a mistake, it won't do. So my advice is, whenever you're typing any formula, to type them in lowercase letters, because when you're getting on some of these quite complex, long formulas, if you've made a mistake, the fact that it doesn't change them to uppercase will help you to locate where that mistake is. So sum, oops, can't type, sum product. Then we're going to open a bracket, and it's asking for arrays. So each of these parts of the formula is called an array, as you can see in our little formula helper just here. So array 1, and this is why SUMPRODUCT can be a bit daunting. It looks a bit scary because it's an unusual looking one. Because we're looking for a yes or no for the first part of the formula, we will start with 2 minus signs. That's telling Excel that we're not looking for it to add up the values here, we're just looking for a yes or a no. And then going to open my bracket. Now, one big difference between SUMPRODUCT and a standard lookup is we cannot highlight the whole column. In order to use the SUMPRODUCT, we need a defined range of cells. Now, in order to future-proof your spreadsheets, as we've been talking about already, you can make that range very big. For example, A2 to A10,000. But you do have to specify the length of that range. And also, every part of this formula has to have a range the same size. Now, I know that I don't have 10,000 lines worth of data in my example, so I'm going to go from cell A2 to A39, because I cheated and had a look at this before we did this. Now, A2 to A39 equals, and then my lookup value is going to be G5. So SUMPRODUCT A2 to A39 equals G5. That's our first variable, our first array. Close your bracket, type a comma, and now we do the same for column B. So we've got two minuses, open a bracket, and we need B2 to B39 equals H5. Close your bracket, comma, two minus signs, open your bracket, C2 to C39 equals I5. And that's all our yeses and nos, isn't it? Close the bracket on that one and type another comma. And remember, for D it's going to be slightly different because we don't want a yes or no. This is where we want it to return a total of the relevant data. So this is just going to be a normal D2 colon D39. I close my bracket, I press enter, and hopefully this will give me £210. Yes, it does. So that's producted each row of the spreadsheet and then summed those totals, and it's given me only the total where all those conditions are true. Now let's just change our lookup a second, because I do have somewhere in here where we have more than one for the month. Now the one we need to be looking at is March for XYZ Limited for a laptop. So I'm going to change G5 to March 11, company name XYZ Limited, and a laptop, and you'll now see more of the power of this function because we have two laptops sold in that month, and it will give us a total of both of them. So we have two laptops sold to that company at £430 each, and it's giving us a total there of £860. So hopefully now you've got an idea of how this works. What I'd like you to do now is to delete the formula if you've just written it in cell G with me, and then I'd like you to build it on your own, and I will help you through as you have any questions.
Neil, this is Naomi. What are the options for these minus signs?
What do you mean exactly?
Well, do you have to use the minus signs on all the... I mean, can you have more than one array without the minus signs?
Good question, and my answer, I hope, is yes, you can. I've not tried it, but let's do some experimenting now. So let's have a look at our formula again. What we have is some product, and then we've got three arrays where we're looking for a yes or no, so we have those minus signs. And then the final one, we don't have the minus signs, so we're just looking for a total, as I said. Now let's add a column to our data for number purchased in transaction. I'll just put number for the moment. I will spell it correctly. So the number purchased in a transaction. And let's put in, well, let's stick on this example that we're using here. So let's say in this transaction they purchased 2. And in this transaction they purchased 3. Now due to the cell formatting it's told us £2 and £3. So let's just put that right a second. There you go. So what we're now saying is we're looking for 2 laptops purchased in one transaction where everything is still matching, the March and the company name and the laptop, and 3 in another. So let's think through it again as we did before. So Excel here was doing 1 times 0 times 1 times the amount, gave us 0. Here we had 1, 1, 1 and 210, gave us 210. Now let's imagine we add a part to our formula, but we don't put in the minus sign, so we're not looking for a 1 or 0. In theory, and as I said, I've not checked this, so let's see what happens as we do it, but you should have 1 for March 11, 1 for XYZ Limited, 1 for laptop, and 430 for the amount. But if we then add another stage to our formula, we should be able to multiply that by 2 if we don't put the minus signs in there again, or as well, and that should give us then 860 here, and here it should give us that times that. Can't do mental arithmetic while I'm live. 1290. So we're expecting a result of £2,150. Let's modify our formula and see what happens. So we're going to put another comma here after our D's, and I'm just going to put E2 to E39. So again, remember, it has to be the same size as the other arrays. That should give us, whatever it was I just said, 1,000 and something, 2,000 and something. Let's see. It does. So yeah, exactly, that's what's happening with that formula, is it's multiplying by 1 or 0 if you're putting the minus signs in, and obviously the equals and the search value, and it's multiplying by whatever is in it otherwise. So to answer your question, Naomi, which I kind of think answers your question, is that what we're doing is we're now able to add as many stages as we want. And yes, this is the first time I've tried it, adding 2 without the minus signs, but what I can tell you as well is that you can have as many of these as you want. It doesn't just have to be 3 plus 1 values one, so you can have this on huge big tables of data. The only thing to bear in mind is if you've got enormous data tables, which is some that I do use in my job, that it can take a little while to calculate if you're on a slow PC, because it's not like a standard lookup. It is going across, as I said, every single row of the data table, multiplying them, summing down, and on 65-odd thousand rows of data, that can take quite a long time. Any other questions?
Could you please show me the formula again?
Yep, absolutely. There you go. So I click back in the cell, press F2. So this is our new formula. So if you now need to copy this, and obviously you can save the example, so you've got a record afterwards and you've got the notes to go with it. There you go. There is the formula that we're using. And I'll leave that with you for another 3 or 4 minutes. I'm still here to answer any more questions that you have. What we'll then look at is some other ways which we can look up complex data sets. So we'll look at concatenating and some backwards and 2-directional lookups. So any other questions, please feel free to ask. Otherwise, I'll give you 3 or 4 minutes to complete this, and then we'll move on.